In the previous class, we have discussed about set and some standard notation like as capital N, Q, Z. Okay. Capital N is what? It is the set of natural numbers. Z indicates the set of integers, and Q set of rational numbers, and so on. These are already discussed. And today we will discuss about types of set. Okay. Actually, set is divided into two parts. One is countable and another one is uncountable. Countable consists two types of sets. That one is first one is finite and other one is infinite. Finite means what? A set containing finite numbers of elements or no element. Okay, that type of set is called finite set. No element means it indicates the set phi. Are you know about phi? I have already told you that phi indicates what? Empty set. Now tell me what is empty set?
Ma'am, a set containing no element.
No element, yeah. A set containing no element, this set is called empty set. And empty set is also a finite set. Okay? Remember this one. Finite set means if a set containing finite numbers of elements or no elements. That means what? Empty set is also a finite set. Okay? Next is what? Cardinality of finite set. Cardinality means what? The numbers of elements in a given set is called the cardinality of that particular set. This is denoted by modulus of A, or sometimes it is written as n of A, numbers of elements in A, and usually it is denoted by modulus of A. If suppose we consider the set A, then cardinality of set is what? Modulus of A. Modulus of A. I have already told you that capital letters A, B, C, D are used to denote the set. Okay. So if we write like as suppose modulus of A, this indicates what? Cardinality of A. Cardinality means what? The numbers of elements of that particular set. Suppose A is a set, A consists the number like as 1, 2, 3, 4, 5. Now tell me cardinality of A is what? Suppose A is a set that contains the elements 1, 2, 3, 4, 5. Then cardinality of A is what? Cardinality of A is what? Hello? Cardinality means what? Numbers of elements of that particular set. Suppose A is a set that contains the element 1, 2, 3, 4, 5. Then cardinality of A is what?
M25.
How can you tell it is 25? Cardinality means I have told that numbers of elements of that particular set. A is a set that contains the element 1, 2, 3, 4, 5. Then how it is 25? A is 1, 2, 3, 4, 5. Count that. 1, 2, 3, 4, 5. Numbers of elements of A is what? What?
5, ma'am.
Yeah, it is 5. A is what? A contains the set elements 1, 2, 3, 4, 5, and cardinality means the numbers of elements. So it is 5. And infinite next one is infinite set. Infinite set means what? A set contain infinite numbers of elements. Suppose set of natural number. Set of natural number, if you consider the set of natural number, then the elements of n are like that 1, 2, 3, 4, 5, 6, and so on. There are infinitely many numbers in that set, and so n is a infinite set. Okay, and Next one is empty set. Empty set means what? A set containing no element. It is denoted by 5. And next, singleton set. Singleton set means what? A set containing a single element. Okay, if a set containing a single element, then it is called singleton set. Okay. Next one is equal set. Equal set means what? If we consider two sets, suppose A and B, then A and B are said to be equal if numbers of elements of A and B are same. Okay, if numbers of elements of A and B are same, then we say that the sets are equal. Suppose we consider A is a set that contains the element A, B, C. Okay, A, B, C, and B is then another set which contains the elements C, suppose A, B. Then see that numbers of elements of A and B are same. That's are what? A, B, C. So we say that A and B are equal. Okay. And next one is equivalent set. Equivalent set is what? If suppose we consider two sets A and B. Okay. Then if the numbers of elements of the two sets are same, numbers of elements are same. Okay, but in the equal set, that is what? Members are same. Okay, elements of two sets are same, but if for equivalent set, if the number of elements of two sets are same, then we say that the sets are equivalent. Okay, suppose if we consider A equals to suppose 1, 2, 3 and B is PQR. Okay, A is 1, 2, 3 and B is PQR. Then the numbers of elements of A and B are what? The numbers of elements A and B are what? What? The numbers of elements A and B are what? Why you are confusing in that concept? Numbers of elements means what? A is a set.
It will be equal, ma'am.
1, 2, 3. It is set contains the elements 1, 2, 3. So numbers of elements of that set is what? Counted 1, 2, 3. How many numbers in that set?
3, ma'am.
3. Don't confuse it. A is a set that contains the elements, suppose 1, 2, 3, 4, 5. Then numbers of elements that set are what?
5.
5. Okay. Suppose we have consider a set, suppose A that contains the elements 1, 2, 3 and B is another set that contains the element P, Q, R. Okay. Then the numbers of elements of A and B are what? Same. Okay, the numbers of elements of A and B are same, so we can say that A and B are equivalent. But is it true that A and B are equal? Is A and B are equal?
No, ma'am.
No, because reason is what?
Because the elements in B are PQR.
Okay, elements are different. Elements are not same. Okay, for equal set, elements should be same. But for equivalent set, numbers of elements are same. Okay, and next one is subset and superset. Suppose A and B are two sets. If every element of A is an element of B, then we say that A is a subset of B and B is called the superset of A. This is right, like that. A is a subset of B and B is a superset of A. Suppose A and B, we are two sets. We consider A equals to A, B, C. Okay, consider A is a set that contains the element A, B, C, and B is another set that contains the element A, B, C, D, E, F. Okay, A, B, C, D, E, F. Now see that every members of A are contained in B. Okay, A, B, C. A contains the element A, B, C, and B contains the element A, B, C, D, E, F. So every members of A is contained in B. So we can say that A is a subset of B and B is the superset of A. Next, suppose we consider the set AC. AC. Okay, A is a set that contains the element AC, and B is another set that contains the element A, D, E, F. A, D, E, F. Now tell me, is A subset of B?
No, ma'am.
No, because
Because B does not contain the element C.
the B contains an element that is C. C does not belongs to B. Okay, so every element of A are not in B, so we cannot say that A is a subset of B. Okay, and next is proper subset. Proper subset means what? A is a subset of B, but A does not equals to B. Okay, then in that sense we say that A is a subset of B. Okay, proper subset of B. And remember this, then every set is a subset of itself. Suppose A is a set, then A is also a subset of A. Every set is a subset of itself, and phi is also a subset of every set. So we can say that the phi and that particular set, phi and that particular set are called improper subset. Okay, phi and that set are called improper subset of A. Phi and A are improper subset of A. If you consider a set A, then phi and A is always a subset of A. So we can say that phi and A are improper. Okay, and rest subsets are called proper subsets. Okay, proper subset means what? A is a subset of B, but A does not equals to. Okay, and universal set. Universal set means what? A set consisting of all possible elements which occurs under consideration is called universal set. Okay, suppose that we consider a set, suppose the B. B. Okay, B is contains the elements suppose 1, 2, 3, 4, 5 up to suppose 10. Then you consider a under set A that contains the elements suppose 1, 2, 3, 4, 5. In that sense, it is called the universal set. Okay, and this, suppose you consider another set, suppose is C. C contains the elements 6, 7, 8. In that sense, we say that U is the universal set, and it is denoted by U. U always indicates the universal set. Universal set is what? A set consisting all possible elements which occurs number of consideration is called universal. Okay, and next is comparable set. Okay, if A is either A is a subset of B or B is a subset of A, then we say that A and B are comparable. Okay, either A is a subset of B or B is a subset of A, then we say that A and B are comparable. Otherwise, it is not comparable. And next is power set. Power set is very important. Power set means what? It is a set. It is a collection of all subsets of A. Suppose we consider a set A, then the collection of all subsets of A is called the power set of A. Okay, in power set of A, the original set and the phi is also comes. Okay, power set of, if suppose there is a formula for cardinality of power sets. Suppose A is a set that contains n elements. A is a set that contains n elements, then cardinality of P of A. That means what? Power set of numbers of elements in P of A is 2 to the power n. 2 to the power n. Okay. Suppose A is a set that contains two elements. Suppose A is a set that contains the elements 1 and 2. Numbers of elements A is here n is 2. Then now tell me cardinality of P of A. Means numbers of elements in P of A is what? Suppose A is a set. A is a set that contains n elements. Okay, formula is this one. A is a set that contains n element. Then power numbers of elements in P of A is what? 2 to the power n. A is a set that contains n elements. Then cardinality of P of A will be 2 to the power n. Now I am telling A is a set that contains two elements. That is both 1 and 2. Then now tell me cardinality of P of A is what?
4.
4. 2 square, that is 4. Okay. Next one is disjoint set. Disjoint set means what? Suppose A and B are two sets. If there is no common elements between A and B, then we say that A and B are disjoint. Okay. Suppose we consider two sets A and B are, then if there is no common element between A and B, then we say that A and B are disjoint. Okay. Suppose consider A equals to 1, 2 and B is a underset that contains the elements A, B. Is there any common element between A and B? A is a set that contains the elements 1, 2 and B is an underset that contains the element A, B. Is there any common element between A and B?
No, ma'am.
No. In that sense, we write as A. There is no common element in A and B. Okay, so we can say that A and B are disjoint. Okay. And next one is Venn diagram. Venn diagram is what? It is a graphical representation of sets. Here we consider a rectangular region which indicates the universal set, and by a circle we indicates that particular set. Suppose here you can see that this rectangle indicates the universal set U, and this one A. This indicates the particular set A. Circle indicates that particular set. Okay. And next discuss about operation on set. Okay. Operation on sets first is union. Union means what? Union of two sets. Suppose if you consider A and B. If A union B is the set of all elements which is either in A or in B or both A and B, and so either in A or in B. So all this part will come in A union B, and this part is what? Common part. Both common part of A and B means this part contains the elements which are both in A and B. So this is what this indicates the union of A union B, union of A and B. Okay, in union of A and B, this is the collection of all sets uh, other which is either in A or in B. Suppose A is a set that contains 1, 2, 3. Okay, and B is a set that contains A, B, C. Then A union B is what? A union B is what? A is
1, 2, 3, ABC.
Yeah, A1, 2, 3, A, B, C. Okay. And the next one is intersection. Okay, intersection of two sets is what? It is denoted by this one. A intersection B, it is the set which contains the common element of A and B. That is, these elements of A intersection B are what? These are terms which are both in A and B. So this is a set, suppose A, and this is a set B, and common element of A and B is what? This one. This part indicates the A intersection B. So A intersection B is what? This is the collection of those elements which are common in both A and B. Okay. Suppose we consider A is a set 1, 2, 3, and B is a set A, B, C. Then now tell me A intersection B is what? Suppose we consider the previous example. A is 1, 2, 3, B is A, B, C. Now tell me A intersection B is what?
5, ma'am.
5. Yeah. There is no common element between A and B. So we can say that A intersection B is 5. In that sense, we stated A and B are disjoint. Okay. Suppose A is 1, 2, 3, and B is suppose only 2. Then A intersection B is what? A is 1, 2, 3, and B is only 2. Then A intersection B is what?
Ma'am.
2, ma'am.
Yeah, 2. It is. Next is complement of a set. Okay, complement of a set is denoted by A dash or AC. It is what? It is the set. This is what which are in U but not in A. You mean suppose A is a universal set. So, sorry, U is an universal set and A is a set. Then complement of A is what? Complement of A contains the elements which are in U but not in A. So diagrammatically, graphically is this one. Complement of A is what? This part. The elements are in U but not in A. Elements are in U but not in A. Okay. Suppose A is 1, 2, 3, 4, 5 up to, sorry, U is 1, 2 up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And A is the 1, 2, 3, 4, 5. And A complement is what? Now tell me A complement is what? U is what? 1, 2, 3, 4 up to 10. And A is 1, 2, 3, 4 up to 5. And A complement is what? A
10,
Six,
ma'am.
complement,
7, 8, 9.
yeah, 6, 7, 8, 9, 10. The rest of the elements of A. Okay. Next, difference of sets. Difference of sets is indicated this way. A difference B. And this is the set which contains the elements like as these are in A but not in B. Okay. A difference B is the collection of all elements which are in A but not in B. Okay, so common part will not come in A difference B. Okay, so this part, suppose A. A is this set and B is this set, so A difference B is what? This one. The elements which are in A but not in B. If we write suppose B difference A, then what we get? The elements are in B but not in A. Okay. Suppose A is 1, 2, 3, 4, 5, 6. B is 3, 5, 6. A is a set 1, 2, 3, 4, 5, 6, and B is a set 3, 4, 5, 6. Then A difference B is what?
One to one.
1, 2. Yeah, only 1, 2. Only 1, 2. Next one is symmetry difference. Symmetry difference is what? A difference B union B difference A. It is denoted by A delta B. A delta B indicates the symmetry difference of the sets A and B. This is what? A difference B union B difference A. So this is nothing else, the A intersection B. So graphically see that this one. A difference B is what? This part. And B difference A is what? This part. So A intersects also. So A symmetric difference is what? A difference B union B difference A. So only this part will come. Okay. So for today I will stop. Is there any confusion?
No, ma'am.
Okay then. For today I will stop.